For lesson 9.12, this is pyramids and cones. We're talking about just volume in your practice packet on page 17. Find the volume of the pyramid or cone, round to the nearest hundredth, 2 decimal places as needed. For the volume of our cone, we have 1/3 pi r squared times the height. So we plug in 1/3 times pi. Our radius goes, actually they give us a diameter here, so our radius then is going to be 3.5. So we have 3.5 squared times our height of 13, which is shown in the picture right there. So calculator problem then, 1/3 times 3.14 times 3.5 squared times that height of 13 gives us a total volume of 166.68, which does get rounded right there, and that's inches cubed. For our next cone, we have 1/3 pi r squared h. So 1/3 times pi, our radius here is 10, and our height in the cone is 22. So 1/3 times pi times 10 squared times the height of 22. It's giving me 2,302.67 rounded square yards. For this one, we do have a square pyramid. So for the square part of it, we're going to have to calculate the area of the base, and it's not a square pyramid, rectangular pyramid, excuse me. So we're going to do length times width for the area of the base. So 14 times 9, and base is equal to then 126. So this is our rectangular pyramid. So that's figuring out the rectangle part. For the pyramid part, our volume is equal to 1/3 area of the base times the height. So we have 1/3 area of the base is 126, and our h value that we identify in the picture is going to be our 20 here. So if we have 1/3 times 126 times 20, that'll give us a total of 840 cubic yards then. Oops, and on this one I did square yards. Excuse me, I'm sorry for that one. Taking a look at question number 4, we have a triangular pyramid. So triangular pyramid. So for the triangle part, I'm going to be finding the area of that base, which is 1/2 times base times height. So I'm going to do the base and the height are at a right angle here. So 6 and 8 are those two pieces. And half of that is going to give me 24. The height of my pyramid is right here at 11. So when I do my volume, it's 1/3 the area of the base times the height. So 1/3 times 24 times 11. And that will give me a total volume of 88 cubic feet then. In the last one, Pablo's Icy Treat Stand sells snow cones in the conical cup shown here. The snow cone fills up the cup and has a perfect hemisphere on the top. What volume of shaved ice is needed to create the perfect snow cone? Round your final answer to the nearest cubic inch. So we're going to go to a whole inch here. So if I look at this one, this is my diameter of 3.5. So if I do 3.5 divided by 2, I get a radius of 1.75. We do have the height on our cone right here is 4. So when I figure out the volume of just my cone, I'm going to do 1/3 pi r squared times the height. So I have 1/3 times pi times 1.75 squared times the height of 4. So we have 1/3 times 3.14 times 1.75 squared times 4. And that'll give me a volume here of 12.82. And that's going to be cubic inches. We have to remember, though, that the snow cone also has that perfect hemisphere. So for sphere, we have 4/3 pi r cubed, but we only have a hemisphere. So we have a half on the top there. So half times 4/3 times pi times the radius will still be that 1.75, and that's going to get cubed. So half times 4/3 times 3.14 times 1.75 to the third power. That hemisphere volume then is going to be 11.22 cubic inches, and that's rounding it off to the nearest hundredth. So my total volume then, I'm going to have to add those together, 12.82 plus 11.22. And that's going to give us 24.04. which we said go to the nearest whole cubic inch. So it's going to be 24 cubic inches then of shaved ice to be able to make that perfect snow cone for Pablo's Icy Treats.